Good morning, Honors Math 2. Today is Thursday, March 19th. It's workout day, so get up, move around today, go outside or work out inside. Alrighty, I will see you tomorrow for Friday, Hawaiian Day, and kick off spring break. Alrighty, we are right in the middle of our conic sections. We've seen two conic sections so far. A circle that is formed when I chop a cone parallel to a base, and that cross section when I chop off that cone will be a circle. And then we saw this conic section where if a plane could intersect a cone parallel to a slant height, and if I could chop off that part of a cone, that cross section would form a parabola. Alrighty, so I thought today might just be a good time to review those two. Your assignment is a review assignment of everything we've seen so far. And I'm going to ask you on Friday to take a couple pictures of select parts of your homework and just submit them so I can see what you've been up to all week. Alright, so if you want to get a piece of scratch paper, I'm going to call this our warm-up for March 19th. You can pause and get a piece of scratch paper. We're just going to do two problems. I'll let you try them. So our first two conic sections, first is the circle. A circle, of course, is the set of all of the conic sections are always defined in terms of distances. So a circle, of course, is the set of all points whose distance from that center point is always the same. And you should be comfortable with the standard equation of the circle, which of course is x minus h squared plus y minus k squared equal to r squared. Alright, I have an example for you. If you can jot this down and try to find the equation of the circle whose endpoints of a diameter are -3, -2, and -3, 9. Try to customize that equation and find the equation of that circle. And pause. Okay, let's see what you came up with. I always suggest sketch the circle because if you sketch the circle, you notice that -3, -2, and -3, 9, those are on a vertical line, so it's a little bit easier to find the center and the radius. The center is always the midpoint between those two endpoints, so the midpoint, the x-coordinate will just be -3 because you notice it's vertical, and the y-coordinate I can average 9 plus a -2 divided by 2, which is 7 over 2, which is 3.5. So the center of that circle is at -3, 3.5. Now, since that's a vertical line, that radius is simply the change in y. How many units between 3.5 and -2? 2 below, 3.5 above, and the radius of that circle is 5.5. And then I can plug into that standard equation, and my equation becomes x minus a -3 squared plus y minus 3.5 squared is always equal to the radius, 5.5 squared. And we would write that as x plus 3 squared plus y minus 3.5, or 7/2 squared, equal to 5.5 squared, and I got 30.25, or you can write that as a fraction. Alrighty, check your answer. And I'm going to give you one other warm-up for a parabola. Okay, our second conic section that we saw is a parabola. And think about the equation of the definition of a parabola in terms of distance. We said a parabola is the set of all points equidistant from a focus and a directrix. A parabola is the set of all points equidistant from a focus and a directrix. Easiest point to find right in between is the vertex, and then we found all of those equidistant points from both the focus and the directrix. We connected those points to form a parabola. That parabola can open up or down. The nice thing about these definitions of conic sections, we're seeing things and equations of things that are not functions. This is not a function. This is a function. What we see next week, hopefully we'll be back together again, is I can turn this parabola on its side, which is not a function, but the definition still allows us to find the equation of that thing that's not a function. So that's the nice thing about conic sections. We're looking at things that are not always functions. But we use the equation for this, which looks a lot like vertex form from before, as y equals, that parabola can open up or down, 1 over 4p times x minus h squared plus k. And that is that vertex form of a parabola defined in terms of distance, where the distance between the vertex and the focus is what we call p. Okay, if you can look for just a second, and you're going to pause and find the equation of the parabola with a focus of 4, 5 and a directrix of y equals -1. Pause and try to find the equation of that parabola. Okay, let's see what you came up with. Again, it always helps me to sketch. Here the focus is above the directrix, so I know my parabola is going to be opening up. The easiest point to find is that vertex. Notice how my units are between 5 and -1. There's 6 units between 5 and -1. So half of that is 3, and I know the vertex is going to be 3 units below 4, 5. 1, 2, 1, 2, 3. And I get a vertex at 4, 5 minus 3, which is 2. Okay, so now I know the vertex is at 4, 2, and my parabola is going to look something like this. I can also find that distance from the focus to the vertex, that's our p-value, and that distance of p in this case was 3. And now I can plug all that information into my vertex form of my parabola. Opens up, so it's a positive fraction coefficient, 1 over 4 times p times x minus h, which is 4 squared plus 2, and the equation of that parabola is 1 over 12 x minus 4 squared plus 2. Alrighty, so that's just a little bit of review. Again, your homework today is a review. Please keep all your homework together from this week and check in on Friday to see what you can turn in, just so I know that you've been keeping up with us this week. I hope to see you on Monday, March 30th, where we'll be moving on with our conic sections. So thanks for getting through these few tasks at home. Take care. Hope to see you soon. Bye-bye.